Hi everyone. In this video, we will check and discuss what is Vasicek model. Let me write it down on the screen. Vasicek model. Okay. Vasicek model is a mathematical tool used to predict how interest rates might change over time, and it also assumes that the current rate interest rate do not move randomly but tend to towards a long-term average. Let me explain what is that. First, let me write the how this model is described by the equation. This is the equation for the Vasicek dRt equal to A of B minus RT dt plus volatility dWt. So in last video we discussed about stochastic differential equation. Even if you observe, this equation is more or less like a stochastic differential equation, but uh, in stochastic differential equation we have a different types like linear, non-linear, and multidimensional, and jump diffusion. These are the different types of SDE that we have, but each type of SDE can be applied in different areas. Coming to the linear type of SDE, which is the Vasicek model or Hull, this is majorly applying to find out the interest rates or mean reverting the models. We can use this uh, type of models in these areas. Okay, now I'll explain what is A, and I mean each term, what is A and B, RT, and volatility, and DWT. So RT speaks about interest rate at time, interest rate at a time T, and B, this is referring to the long term average interest rate, long term average interest rate, and A refers to interest rate at time T, interest rate at time T, and we know this is the drift term and this is a random or diffusion term. Okay, and this is a volatility, is a diffusion. Let me write this is also, this is a drift term, and DWT is which models are randomness, in our case Brownian motion. So I explained detail about Brownian motion, how we derive it, and intuition, and also explained with one example. I request you to refer my old videos on Brownian motion that you can find in my channel in XVA playlist, or otherwise I can provide the links in the description. So now we will discuss you know few of the assumptions and limitations that follows by Vasicek model, and let me write it down the limitations also. This model, I mean this Vasicek has some limitation. One is that interest rates can go negative. Like I mentioned before, there are different types of SDE, right? Stochastic differential equations. So if any of the time that, I mean, so in sometimes we have to use these models or equation in different areas, like calculating the bonds. At the time, then we do not need negative interest rates. At the time, then we have to use the different models than this Vasicek. So other models like CIR, these are the models. This is a non-linear. These are the type of models which fix those negative rate issues. but this is the one of the limitation for this Vasicek model. And also let me write it down the assumptions for this model. The first assumption is a mean reversion, means rates always revert to B. B means we already know that long term average interest rate revert to B at speed A. And this is the one of the assumption. And second assumption is our parameters are constant. It do not change over time. Parameters are such as like A, B, and sigma. These are the parameters do not change over time. This is another assumption that we take for this Vasicek model. Now let's see the equation in detail. Now let me change my colors. dRt equal to A of B minus RT dt plus volatility dWt. So if you look now, this A speaks about the mean reversion speed. It means like it helps us how fast the rate of return again become to the average. This is the average rate, right? This is a rate of return. So this is mean reversion speed. And this is talking about volatility, and this is a Brownian motion. And now we'll see, here we have to understand few more things, like suppose if our rate of interest greater than B, which is the average long term interest greater than B, then it drifted to negative and rate decreases. And if my RT less than B, then drift is positive, means rate increases. Okay, and we also know that volatility speaks about the randomness. And I was referring to, this is the term which is this is the term A into B minus RT dt is a linear. This is what I was referring to, the linear means, meaning that if in simple terms, first see what is the linear meaning. Linear means something that changes in a straight line fashion. Suppose if I take the graph, and if this is the straight line that I take, and let's imagine x-axis is either time or distance, and y-axis either height or amount. Okay, so what this straight line of the graph it says, we move along the horizontal axis from one point to the another point. The value of the vertical axis, okay, value of the vertical axis also increase or decrease at a constant rate. In this example, our graph I draw in this way, but if this is written in this way, then our rate of change decreases at constant, correct? So this is what the linear relationship explains about. In the same way, in Vasicek model also, the drift term, which is A into B minus RT, this is a linear, meaning that it pull or it brings the interest rate back to long term average. Let me write it down on my screen. It pull or force that brings the interest rate RT back to the long term average B. So we can also say this is the form of B. Okay, and this follows a relationship like a straight line. That is what this drift term is a linear. Now we have seen all the components in the Vasicek model, and we know each of the term. And let me explain with one of the example. Okay, and let me take few of random uh, random numbers for our calculation. A is the mean reversion speed. B is 0.05. This is a long term rate, which is a 5%, and R 0.05 is a 5%, is a current rate, current interest rate, and the volatility 0.01, volatility 1%. And imagine we are trying to find out the changes of interest rate for 3 months instead of one. So my time step dt, I'm just trying to find out 3 months 0.25, and random shocks, because this random shocks and variance, these are all important to calculate the Brownian motion. I request again to watch my earlier video so that you can understand better about Brownian motion. And here I'm not walking you through how we calculate the Brownian motion. Here I'm directly taking that value. So dWt, I'm just taking this 1 for simplicity. This is the standard normal random number. First, let me calculate the shock, which is volatility into square root of dt, which is a very standard deviation, into dWt. So I know my volatility is 0.01 multiplies, and dt time step that I am taking, this is the variance, and the square root of variance, which is a standard deviation 0.25, and multiply dWt, which is a 1. So after I calculate 0.01 into square root of 1, square root of 0.5, which is 0.5 into 1, so finally it is 0.005. So this is my shock value, and let me calculate the drift value also. Drift value, we know this is the A into B minus RT and the dt. 0.15 is my A value, which is a mean reversion speed, and if it is a high, then it is the interest rates bring back more with more speed. That is what the mean reversion rate. So B is a long term average rate, in our case 0.05, and even current rate also 0.05. So and into dt, which is dt is, we know our step is 0.25, right? So if I multiply all this thing, then I'm going to get, obviously this is a 0, and 0 multiply with 0. So our drift is a 0 now, and I know the shock. And what is the another component? Yeah, we got everything in to substitute these values in our equation. So what is our new rate? Then our old rate I know, that is a 5%, which is a 0.05, and I'm just adding my drift term is a 0 and my shock is 0.005. So I can say that 0.5055, which is 5.5%. After 3 months, I can expect that interest rate changes 5.5%. This is how we use the Vasicek models to calculate the interest rates. I hope I'm clear with this one. Let me give another example. Suppose if my random term is -1, okay, I'll let me calculate again the shocks, which is 0.01 is our volatility into square root of 0.25, which is a step that for variance, and here z value is a -1 random. Here randomly I'm taking this -1. So after calculating this 3 again, I this time I'm going to get 0.005. So I got my shocks now, and let me calculate the new rate. And I already know my drift term here, which is 0, because there is a no difference in my drift. So my new rate now, which is earlier rate is a 5%, 0.5, 0.05, plus my drift term is 0 only, and the new shocks that I got it minus 0.005. So after calculating this one, this becomes 0.045, which means 4.5. Suppose if randomly if I take -1, a random number that we take it in a Brownian motion as a z, right? This is a z value, right? As a -1, then I'm going to get or end up with the new rate 0.045, which is a 4.5%. So this is how we calculate interest rates using Vasicek model. And in my next video, then we'll discuss more about where this Vasicek model comes into the picture and how we use Monte Carlo simulation and how finally we are calculating the CVA and DVA values. That's it for this in this video. Thank you.